Our group is 31, and my teammates are Nishtha and Soham Gundewar. And today we are presenting our final project, bone fracture detection with neural networks. So the basic idea is that fracture detection is very crucial at early stages in healthcare, but the manual analysis basically is very slow and it can lead to human error. So our idea is to develop a deep learning model that not only classifies if the fracture is present or not, it should also localize of a presence of fracture in that X-ray image, so which improves both diagnostic accuracy and efficiency. The dataset is bone fracture YOLO uh, and which is freely available on Kaggle. It contains X-ray images with 7 different fracture classes like elbow, knee, fingers, etc., along with the bounding boxes coordinates that highlight the location of the fractures within those images. So as you can see here in image, this is an example of an elbow fracture, and so the red square you can see is the location of the fracture bounding box, and the 0 is the class label of the elbow fracture. So as you can see, this kind of images provided to the model. Okay, so let's move towards data preprocessing. So yeah, as our database has some class imbalance presence, like class one has, which is elbow, has most of the zero class, which is has the most of the around 3,000 samples, more than other classes on average. So we perform some data preprocessing. We resize images of other classes which have lower samples, converted to grayscale, vertical, horizontal flipping, common machine learning techniques that we use in data augmentation and rotations, and obviously followed with a normalization. So we for baseline we tried two models, k-nearest neighbors and support vector machines. And our proposed model is actually CNN with transfer learning where we used ResNet 50. And yeah, our train test split is 80% training and 20% testing. So these are our metrics: accuracy, precision recall, F1 score, confusion matrix, standard metrics used in machine learning. One interesting metric is mean squared error of IOU. IOU is basically intersection over curve, which basically measures the square difference between the IOU values of predicted IOU values and actual IOU values in multiple samples, which I will show this in the next slides. So as you can see in the slides, this red square is basically a labeled bounding box in the input, and the green is the predicted one. So it basically calculates the difference. MSE is basically calculate the difference between these two bounding boxes. And the lesser the MSE is better, and higher the IOU is better. So let's start with the performance of our baseline model. So as you can see, KNN gives a fair accuracy of almost 70%, and you can see it performs very well for class 1 and class 4. It performs very poorly and misidentifies class 5 and uh, class 2. So, and we got the best results at when the K is 4, number of clusters is 4. Okay, so let's move towards the SVM. So SVM obviously gave better accuracy with RBF kernel, and we got 0.82 accuracy, which is 82%. And if you can see, it performs very well on different classes. Class 1 and class 4, it performs way better. And also it gives more than 50% accuracy for even other classes like class 2, class 3, class 3. We still need to perform better for class 5 in this case. So yeah, these are basically samples of bounding boxes here, and how well it predicts on KNN and SVM. As you can see clearly, SVM perform a little bit better than KNN. You can see the green boxes and red boxes are intersecting better than in the KNN. So yeah, our model architecture is CNN, and we have used transfer learning model ResNet 50. It's pre-trained, and so basically there are two tasks. Basically classification. First, we need to identify if there is a fracture or not. If there is a fracture, then which class? Like, is it elbow, finger? We need to classify it into 7 different categories. And there is the regression where we calculate the coordinates of the bounding box to localize or to detect where the presence of the fracture within the X-ray image provided. And yeah, these are a few multitask learning we have used across entropy loss and smooth learning. And we, yeah, train it jointly with both fracture type and location prediction. So this is our model performance. So we get fair accuracy of 85%. And as you can see, model performs almost way better than compared to what KNN and SVS performed. As you can see, there are very few false positives and false negatives, which are very important in this case. And yeah, these are our results. Total getting, we get accuracy of 85%. And yeah, these are classification accuracy loss and bounding box related loss. And yeah, as you can see, IO images. This is the very important part. So as you can see here, the bounding boxes are almost aligning way better than KNN and SVM. And so IO is way higher and MS is less in this case. So prior work is, so we two members have prior worked on CNN architecture, worked on object detection, classification using TensorFlow and PyTorch. A third member works in computer vision, and he had work on hands-on work experience in using OpenCV, using data preprocessing, normalization, augmentation, etc. So I think we have kind of very strong foundation for this project. And these are our results. So KNN we got fair accuracy of 70%, SVM 82, and for ResNet 50 transfer learning model we got 85. Yeah, I think that concludes our model. We still needs to work further on fine-tuning our SN50 model and explore some other ensemble methods available. And so we need to improve work on this IOUs and how we can improve our localization uh, of the fractal within the image. And these are our references. So these are data set, and these are some papers that we referred which use both like KNN SVM and a transfer learning uh, idea and how we can pursue that.